Good afternoon, everyone. Carasoft Technology would like to welcome you to our Google Cloud webinar, Federal Healthcare Innovation. Before we get started, I would like to go over a few housekeeping items. The audio portion of this webinar can be heard through your computer speakers or by entering your number in the dial-out option on your screen. All lines have been muted to reduce any background noise. If you have any questions about the presentation, please use the chat pod on the left side of your screen, and we will do our best to answer all of your questions at the end of the presentation. If for some reason we do not get to your questions, our team will certainly follow up with you offline. Just to tell you a little bit about Carasoft, we are a trusted government IT solutions provider delivering software and support solutions to federal, state, and local government agencies. Carasoft maintains dedicated teams to support sales and marketing for all of its vendors, including Google, F5, Symantec, Adobe, and Red Hat. Our contact information will be at the end of the presentation, so please do not hesitate to call or email us for any of your needs. This webinar is being recorded, and a copy of the presentation will be emailed to you. At this time, I would like to introduce our speaker for today, Jeffrey Vasquez, Customer Engineer, Google Cloud. Jeff, the floor is all yours.
Awesome. Thanks, Harper. Just want to confirm that you can hear my audio.
Yes, sounds great.
Okay.
And your
Cool.
screen looks good too.
All right. Okay. All right. With that, let's get started. First of all, thank you, everyone, for taking time out of your hectic schedules to meet with us today. We know you're all extremely busy, so really do appreciate it. Now, today, we're going to take a look at some innovative AI, ML, and big data solutions around healthcare that we've been working on at Google. And also kind of look at some ways that you can leverage these technologies to do amazing and transformational work. Now, before we begin, let me go ahead and introduce myself. My name is Jeffrey Vasquez. I am a customer engineer with Google Cloud, focusing on federal healthcare customers. I work with customers like the FDA, CDC, and CMS. I've done work with other FedCiv organizations or agencies like NASA, the NIH, as well as many state and local government customers. On a more personal note, my wife and several of my family members are RNs or nurses, and so I get to hear directly from them some of the struggles they deal with on a day-to-day basis. And I like to think that the work we're doing in healthcare tech is in some way making their jobs easier and directly impacting the quality of healthcare their patients are receiving. So with that, let's continue. Okay, so a common question we get is, why is Google doing cloud, right? We had a lot of success in like search, YouTube, maps, a bunch of different products. Well, the reason why we do what we do, the reason why, or our mission at Google Cloud is really about one thing. It's helping organizations solve their biggest problem or their biggest problems. So Google has a rich background of innovation, and it's with that innovation we'd like to help you solve your biggest problems. That's really what it's about. So what are some problems plaguing those of us in healthcare? Here are a few things that we've heard from the field, from various doctors, nurses, PhDs. I'll read a few of them. We need to be able to search and filter patient information faster. I'm sure many of you have heard that before. Or how can we de-identify our data, whether it be text or images, and automatically strip away any PHI or PII? How can we speed up cancer research? Or how can we innovate with our data when it's all over the place, inconsistent and unstructured? So today we're going to go over some solutions that can help you as we work to solve these big problems. So why are other healthcare and life science organizations using Google? So I'm not going to read through all of these, but just to highlight a few, you can see that American Cancer Society is analyzing image data 12 times faster using Cloud Engine, one of our ML products. The Broad Institute, using BigQuery, our data warehousing tool, is analyzing human genomes 400% faster. Ambra Health is leveraging our Cloud DLP, or data loss prevention product, to easily anonymize patient data. It's de-identifying patient data automatically to create an open source data set for global collaboration. So these are just a few examples of some of our healthcare customers and what they're doing to be transformational in the industry. So at Google, we have 9 products with over 1 billion users. No other organization can say they have the same. Now, we don't say this to brag. We don't say this to toot our own horn. But the reason why we bring this up is because it takes a tremendous amount of infrastructure and innovation to make this happen. And it's with that same innovation, that same technology that we provide to our customers that use Google Cloud. So this is how we're helping organizations leverage the best of Google's innovation to solve their biggest problems, especially in healthcare. So what are some other reasons to consider Google Cloud for healthcare? Number 1, our healthcare and life sciences engineering expertise. So we have a dedicated engineering team whose sole purpose is to create healthcare-specific products and solutions. That team staffs domain experts like MDs, PhDs, and RNs, folks like yourselves that know this industry firsthand and understand the problems that you all face. Today, we'll take a look at some of the leading-edge solutions that this team has built, such as the Healthcare API and many industry firsts in ML and AI, or machine learning and artificial intelligence. We also have a partner-led strategy. We know we can't scale without our partners, and that our partners have that really deep healthcare expertise and experience. We also understand that these strong relationships that customers have with our partners is integral to our success, their success, especially the success of our customers. Number 3, healthcare-specific security and compliance. Now, compliance is something Google takes very seriously with our HIPAA, BAA, FedRAMP, and many other certifications that we've acquired to make sure that you're in compliance. And then lastly, we've partnered with numerous healthcare and research organizations like the NIH and CMS to provide important public data sets that anyone can do analytics on. And in that situation, Google pays for the storage, and all customers have to pay for is doing queries or the compute against that storage. So as you can see, healthcare is a vertical that Google is taking very seriously. So in general, there are a lot of things that make Google Cloud different from other cloud providers. Things like our global private network, which help make Google search and YouTube so fast. Sure, many of you have used YouTube or search in the past, and it's a pretty quick product. Around security, our Titan chip, that's on all of our hardware and peripherals. That Titan chip establishes a hardware root of trust to make sure nothing's been tampered with. We have a very unique philosophy around supporting multi-cloud, right? You're not going to hear that from a lot of other cloud providers. And then, of course, our advanced big data, ML, and AI platforms. But today, we're going to focus more on our differentiators when it comes to healthcare. So I mentioned compliance earlier and how it's built into our products. We have certifications around HITRUST, HIPAA, and FedRAMP. On top of this, we have other security features like encryption at rest by default. So notice by default, that's different than others, the way others are doing encryption. These are the type of security features that really help you meet compliance. And one thing I did want to mention about our cloud is that we don't have a separate Gov cloud for compliance. We have one cloud for both commercial and government customers that meet these compliance standards without you having to pay more to use a separate Gov cloud. We've often heard customers complain about feature parity between a Gov cloud and commercial cloud. We don't have that problem at Google. We just have one cloud and you pay the same price for it. Okay, today we're going to take a look at these 3 platform layers when it comes to building healthcare solutions. Number 1 is data. We understand the issues surrounding healthcare data, like data being stored in disparate systems and in different formats. The sheer volume of data we're working with and the issues surrounding storing that data and scalability. These issues around data make it extremely difficult to get the most value and insights out of your data. So today, we'll take a look at some ways to help solve these data problems. Number 2, cloud services. Once we solve the data problem, how do we leverage the hyperscale and intelligence of the cloud to build tools that solve our industry's biggest problems? And then lastly, number 3, we'll take a look at some examples of applications that you can build on Google Cloud to address these issues. So we have some pretty cool demos which we're going to show you today. All right, let's talk about data. So Unfortunately, healthcare data is messy. I'm sure all of you know this, or most of you know this. It's siloed. It's stored across different parts of a system or in different systems. It's unstructured, and we generate a lot of it, more than ever before. Here you can see some examples of the old standards, like HL7 and X12, some of the newer standards, like FHIR, and then some opportunity for standards around social and wearables. Now, how do we go about addressing the messiness of all this data? We'll talk about our Cloud Healthcare API and how this can help you around this data problem. Here you can see an example of doctor's notes. So my wife as a nurse, she's had to deal firsthand with trying to decipher doctor's notes. It can be a pretty interesting exercise. You can see from this example the different punctuation irregularities, abbreviations, and even Latin. And it can be really difficult to make sense of this data as clearly depicted by the meme. What if there was a way to teach a computer to learn how to interpret this and make sense of this information? Well, with the power of machine learning, which we'll show you a little later, there are ways you can train a computer to help make sense of information like this faster. Okay, let's take a look at some cloud services and applications to help solve this data problem. All right, so GCP, or Google Cloud Platform, has over 60 products, which we're going to cover in depth. So please make sure to take notes, and we're going to have a pop quiz right after. No, I'm just kidding. Don't worry, we're not going to do that. Point of these slides is to show you the magnitude of cloud services that we offer. And don't worry, we're not going to go over each one. You can see Google really likes hexagons. See, more hexagons. But instead of focusing on all the different cloud products, let's jump to healthcare. So the highlighted services or tools are the ones that we're going to focus on today. There's a lot more we can cover, but we simply don't have the time. But you can see we'll cover the Healthcare API. We'll cover BigQuery when it comes to analytics and data warehousing. And then under machine learning, we'll talk about data loss prevention or de-identification, natural language processing, Cloud AutoML, and Cloud ML Engine. Okay. Let's start with the Cloud Healthcare API. So in a nutshell, the Healthcare API allows you to ingest clinical data at scale and standardize on FHIR and DICOM formats, so that once it's been standardized on those formats and once it's in one place, you can use cloud tools like machine learning and analytics on that data. It helps solve problems. It helps solve the problems around data interoperability, data silos, and data sprawl. It supports the latest formats, HL7v2, FHIR, and DICOM. And really what it does, it just makes it easier and possible for you to leverage the cloud and machine learning on your data without you having to make your own huge infrastructure investments. It's probably easier to explain if I show you this diagram. So you can see, if you look at the top layer here under data sources, we'll start from a position of disparate, loosely connected systems. This is often the case in practice, which I'm sure many of you can attest to. They speak different formats, they have different API capabilities, and they support different functions in your organization. In addition, you'd want to build support here for products like wearables, like Fitbits, Apple Watches, and different sensors. Now, to bring this data together is a necessary first step in data translation. So you can see here, this translation layer here. What's happening is we're taking all of that data that was all over the place and in different formats and different structure, and we're standardizing all of it on FHIR. And we're doing this through a series of open source tools, managed services. There's different ways that you can do this translation. And once it's been translated and standardized on FHIR, then you need a single place to put it. This is where data needs to land. So here we have our Cloud Healthcare API. This one is specific to FHIR. So here's our FHIR store, and this is where you have your single canonical source of truth. All of your data will reside here in FHIR, and imagine how powerful all this data will be once you can use machine learning on it, or analytics, or even build your own applications and leverage that data for your apps. So you can see here, this layer right here below the Cloud Healthcare API layer is about building your applications, about doing analytics, and about leveraging machine learning. So imagine having to build your own scalable healthcare data solution on your own and the amount of investment and labor that it would take. We at Google have already built it for you in a way that's cost effective and allows you to take advantage of the latest AI and ML technologies. On top of this, this is built on GCP, so you get the security, the reliability of Google Cloud, all built into this product. Okay, now let's take a look at big data and analytics with BigQuery. All right, so BigQuery is our fully managed serverless data warehouse solution. It allows you to store exabytes worth of data. That's right, exabytes, not petabytes, terabytes, exabytes. And you can do analytics at petabyte scale. I think the last estimation is something like 15 to 20 seconds to do analytics on a petabyte's worth of data. Now that's pretty amazing. You don't have to install any hardware. You don't have to install any software or do any software updates. All of that is taken care of by Google. You don't need a DBA to get started. If you're a data analyst and you know how to do SQL queries, you can get started right away. Simply just log into the BigQuery console, you load your data set, and right there you can start doing your queries. You can also see a sample of cost savings there on the bottom that some of our customers have experienced by moving to BigQuery. There's one customer that lowered their TCO over 3 years by 41% switching from Amazon. And then another customer that lowered their TCO over 3 years by 52% when they moved to BigQuery from their on-prem solution. And again, because it's a managed service, Google takes care of the encryption, the durability, and the high availability of the system. So with that, let's go ahead and jump into our first demo. So there's a public data set that CMS has partnered with Google to provide. And the question we're going to want to answer on this data is, what is the most prescribed medication in each state? So again, if you wanted to run your own analytics on this data set, you could. And Google is paying for the storage. You'd simply just have to pay for your queries. All right. So here is the lovely actually, hold on, my screen locked. Let me unlock my screen. Sorry, my screen locked. Harper, can you verify that you can still see my screen share?
Yep, it looks good.
Okay, great. Sorry about that. All right, so let's kick off the demo. Okay, so here's the lovely BigQuery, actually GCP console. So this is what it looks like when you log into GCP. This is the admin portal or admin console that you'd see. Now we're going to access BigQuery. So we're going to scroll down under Big Data. We'll click on BigQuery. And here is the BigQuery console. So again, nothing to install. You simply access it through a browser. Now, you heard me mention that Medicare has public data sets available on BigQuery. You can see there's over 150 public data sets that you can access that are available in BigQuery currently. So let's look at the Medicare BigQuery data sets. Go ahead and open this up. Okay, so here are some sample queries that we've provided. What is the most prescribed medication in each state? Let's click on Run this query. Here's the BigQuery console again. It's automatically populated the SQL query. Now, so that I'm not cheating, I'm going to go ahead and disable cached results, because if I used cache, it would take under a second to run this query since I ran it recently. There's a question we're trying to answer. Now, look, if you know standard SQL, you can start using this right out of the box. Let's scroll down a little bit. Here's the table that we'll be running the query against. So it's data from 2014, Part D prescriber. And the output, let's look at the top 5 most prescribed medications in the US by state. Now before we run, it shows here the query will process about a gig's worth of data. So it's not a huge data set, but good for a demo. So it's querying, it's running, and boom. In 3.1 seconds, we've gone over a gig's worth of data. We've gotten our results here on the bottom. So it looks like levothyroxine sodium, it's a thyroid medication, is the most prescribed medication in California. Same for Florida. Texas is hydrocodone acetaminophen. You can see the total claim counts, cost in millions. So again, 3 seconds to run that query. Now let's dive a little deeper into the details of this query. So if you look under the execution details, we went through 24 million rows. So 24 million rows in that data set that we went through in 3 seconds and had it filtered down to 5. That's pretty quick, right? Pretty fast. Let's say we wanted the top 10 most prescribed medications in the US by state. Let's run it again. Again, no caching here. And in 3.2 seconds, we're able to run it, and now we have the top 10. So that thyroid medication you can see is prescribed quite a bit. So again, the execution details. You can see some information about the job. So again, we went through a gig's worth of data in 3 seconds. If you want to save the results, you can save it in CSV or in JSON. So if you want to integrate it into your application, you can do that with JSON. Google Sheets, you can save those results. Now let's say you wanted to visualize this data, right? So there's, let me pause it here. There's integration with like Tableau, Looker. Today we're going to show you how to visualize with Data Studio, which is a Google product, which is free and natively integrated with BigQuery. So based off the query we just ran, we're going to try and visualize this information. It's a lot like Power BI and Tableau and so forth. So I clicked on Open with Data Studio. So this automatically opened up. Let's say we wanted a bar chart to see the most prescribed medications. So here, let's put the drug name under dimension. And then let's take the total claim count and use that as the metric. Cool. And then let's go ahead and do a bar chart. And there we go. So the thyroid medication we looked at has almost 14 million claims in 2014. So that's prescribed quite a bit. Also hydrocodone, acetaminophen, 6 million. And then I'm not even going to try and pronounce that, but 2.6 million for that medication. And so we did a query on a decent amount of data, and visualized it, did all that in under 10 minutes. So it's pretty amazing, the kind of insights you can get and how quickly you can get that information without having to invest in your own infrastructure to do so. All right, let's do machine learning and AI. Okay. Machine learning and AI. Actually, let me move this. There we go. Excuse me. Okay, so when it comes to ML and AI, we'll start with de-identification or data loss prevention. So Google's de-identification technology, which is part of our Cloud DLP product, leverages machine learning to redact or replace identifying information. Now, Cloud DLP has over 90 built-in info type detectors, including the HIPAA 18. So data types like names, locations, age, and phone numbers. It can detect these data types automatically without you having to train your own machine learning models. So the awesome thing here is that typically you would need to create your own ML model or your own rules-based tool. But here, you can leverage the power of Google's pre-trained machine learning models on your data set to automatically strip away any PII or PHI. This can be done with just a few lines of code, or you can leverage the native DLP services built into our storage services like BigQuery or Google Cloud Storage. Okay, let's actually show you a live demo now. So this application that we've built here actually calls on the Cloud DLP API to remove any identifying information. It's a REST API and it works in real time. So here, I'm going to go ahead and type in some patient information, patient name, Michael Jordan, phone number. Let's try residence. Okay, so you can see as I type, it was automatically redacting the personal identifiable information, as well as it replacing it with like a classification or a category, right? So it's pretty powerful. It's fully configurable. You could have it put surrogate information in there if you like as well. So there are different ways to configure this tool. And we had a video just in case the demo had issues, which it didn't, and it's never had issues, so that's great. All right. Okay. Awesome. Let's go ahead. So you saw me do that demo on text data. So the Cloud DLP product also works on images, which is cool. It works against burnt-in text that's burnt into the pixels of images, as well as text that's been overlaid through something like a DICOM viewer. Let's go ahead and show you this in action. So here we've built an application that allows you to upload photos or images. And once you've uploaded the images, the application calls on the DLP API to strip away or redact or black out any of the PII within the image. So here you can see we have a sample X-ray image. It has names and condition there on the right. So there, Jane Smith has information like date of birth and the condition here. Now we're going to upload this X-ray image to our application that's using Cloud DLP. It's uploading. And then boom, there it's found the PII. It's automatically redacted it or blacked it out, blacked out the condition. Now, if you wanted to, there are options where you could just highlight the PII. And there are also options where if you wanted to, you can redact all the text in the image. There we go. It's pretty powerful, right? Considering the fact that it's an image and not text. Okay, so that was our Cloud DLP API that we just showed you. Now, another popular machine learning tool that customers tend to use is our Natural Language Processing API or NLP API. So this API allows you to gain a better understanding of the meaning and the sentiment of text. With NLP, you can extract information about different things from your text-based documents. Things like people, places, and events. So it's great for doing things like sentiment analysis or content classification. So let me actually show you an example or show it to you in action. So here's a demo of the NLP API. So right here, what I've highlighted here is text that's been grabbed from a news article and it was pasted into this box. Let's go ahead and analyze that text. I am not a robot. And here you can see it's taken that text and it's broken it down. So it's been able to identify different parts of the text and classify the content. For instance, Google, it's classified it as an organization, right? Or Mountain View is a location. It included a Wikipedia article about that information or about that content. Sundar Pichai is a person. It provides a salience score, so you can tell how prominent certain things are in the text. So if we scroll down, this article, is talking a lot about phones. So you can see the salience score of phones here. Actually, right here, 0.1. So a little higher salience score. Additionally, you can do sentiment analysis. So of this text, the scoring would be from -1 to 1. And here, it's a pretty positive article talking about phones and Google. You can see that through the scores of like 0.5, 0.1. Here you can see phones is 0.7. That's pretty high, right? So it's talking about phones in a pretty positive light. If it was a negative article criticizing the phones, you would most likely see like a negative score for sentiment here. There's a syntax, so you can see like how many nouns and verbs and so forth are within your text. And then categories. So here it categorizes the entire article with a confidence score. So here it's pretty confident, about 60%, that this article is about mobile and wireless. So you might be wondering, how does this apply to healthcare? Well, if you think of like customer satisfaction surveys that hospitals send out or patient safety reports, right? You could easily find out the sentiment of those reports or of the feedback from patients. Understanding what issues are plaguing that organization the most, right? Or understanding, why certain patients might be really unhappy, and being able to do that quickly, leveraging like this natural language API. Okay, there we go. All right, so now let's talk about Cloud AutoML. So this is one of our newer products. Cloud AutoML is an entire suite, actually, that enables non-data scientists with limited to no machine learning, allows them to create like their own high-quality ML models for things like images, videos, natural language, and language translation. So you can use AutoML with little to no code and start creating ML models right away, again, through the same GCP console. So I'll show you a demo. In this demo, we'll be uploading a bunch of images of clouds, and we're going to label those clouds, and we're going to use this labeled data to train an ML model to predict what kind of cloud is in a picture. So by the end of the demo, I'll be able to upload like a random picture of a cloud and have my ML model tell me what kind of cloud it is and like what percentage of certainty that cloud is. So let's go ahead and jump right in. So again, we're back in the GCP console. First place we're going to want to go to is Google Cloud Storage, because this is where I'm storing a bunch of images of clouds. So let's go to Google Cloud Storage. You can see there's my storage bucket. And here I have a bunch of pictures of cirrus clouds, cumulonimbus, and cumulus clouds. So within each folder, I'll go ahead and open one. You'll see that we have about 20 images of these kinds of clouds. So those are the cirrus clouds. And you'll see that I have, here, I'll pause it right here, that I have a CSV file. Now what this CSV file has is has all the labels for those pictures. So one column will have a URL to all those pictures that we've uploaded to our storage. And then the next column will have its corresponding label. So one link will have like a cirrus cloud. The next link will be like cumulonimbus. And this is what we're going to feed our ML model. These are the examples we're going to give our ML model to make it smarter. And just to make it easier, I'm going to name my ML model Cloudbot, just for fun. Okay, so now we have our images, our training data that we're going to feed Cloudbot to make Cloudbot smarter. So Cloudbot can tell me what kind of cloud is in a picture that I upload. Let's scroll down to Vision under Artificial Intelligence, AutoML Vision. Let's open it up. Okay, so now let's load our data set. Let's name our data set clouds. We'll do a single label classification so that just whatever picture we upload with a cloud in it, it'll choose just one type of label. Okay, here's where we're gonna upload the CSV file that has all the labels for all my pictures. So let's browse to my cloud storage bucket. There's my CSV file with the information to feed Cloudbot. Let's click Continue. All right, so it's loading those images. It's importing them now. And this normally would take longer, but I fast forwarded through it so you didn't have to watch a spinning wheel for 15 minutes. Okay. So now we have our images that have been imported. Let's fast forward a little bit. All right, let's take a look at these images. Okay, so these are the images that have been imported into our Vision API service from my cloud storage. You can see pictures of cirrus clouds, cumulus, et cetera. It's all labeled data now, and we can filter it. So here, all my pictures of cirrus clouds, all my pictures of cumulonimbus. So you can see that the CSV file worked. It was able to apply the labels to these images. So now we have the data, the examples, to feed Cloudbot and make Cloudbot smarter. You can see we have about 20 images of each. Ideally, you'd want to have about 1,000 images, but for the sake of the demo, we just did 20. Okay, so now let's go ahead and train Cloudbot. So the images are imported. We can start training. Here's where we would name our model. I'll just use the default cloud hosted. Here's the node hour budget. Since it's just a demo, save some money. So we'll change that node hour budget to 1. And we'll start the training. Now we're feeding our ML model those images, and it's training. It's getting smarter. Normally that takes about 20 to 25 minutes, but I fast forwarded that so you don't have to sit through it. And there we go. Okay, so now we've trained our model with those images. You can see the average precision is about 97%, which is pretty good. So we had some good data that we fed Cloudbot or our ML model. Let's go ahead and evaluate. You can see that based off the data we provided our ML model, the precision score is about 83%, which is pretty good. We'll have fewer false positives. Could be better if we uploaded more images, but it's a good start. Recall, fewer false negatives, about 83%, which is also not bad. Again, the more images you feed it, the higher those percentages become. Okay, so let's go ahead and test Cloudbot. Before we do that, we have to deploy the ML model or deploy Cloudbot, and we need to run it on some nodes. So we'll just deploy it on one node. Okay, let's deploy Cloudbot so Cloudbot can start doing predictions on what kind of clouds are in a picture. All right, so our model's been deployed. Cloudbot is ready. So let's upload some images of clouds, and let's see what Cloudbot comes back with. I have two images here that I'm going to upload. And it predicted the first image is cumulonimbus with 99% certainty, and predicted that the second image is of cirrus clouds with a pretty high percentage there, a score of 1, which is really good. So as you can see, like in under an hour, without writing any code, setting up any infrastructure, we were able to create an ML model that could predict what kind of cloud is in a picture. So you might be wondering, how does that apply to healthcare? Well, imagine being able to train an ML model to understand what kind of X-ray images were healthy versus those with bacterial infections, right? You could go ahead and label a bunch of different X-ray images and feed your model that way and have it do predictions. That way, you don't have to have humans always, spending a lot of time reviewing that. This can really help speed up that kind of process and diagnosis. So that's one example that I've seen people, do some testing on, right, with X-ray images. Okay, let's go back to the slides. All right, so you saw us show our machine learning APIs that are pre-trained that you can access right away, which really puts machine learning in the hands of developers without them having to be a data scientist. We've looked at Cloud AutoML, which allows you to create your own ML models without having to write a lot of code. And lastly, the one we want to talk about before we conclude is our Cloud ML engine. So this is for all you data scientists out there. How many times have data scientists had to request high performance computing resources, right? Or install their own machine learning tools and frameworks? So this can be a hassle and often takes weeks to get set up for our data scientists before they can even start doing any data science work. With Cloud ML Engine, we can provide you the compute resources you need on demand, complete with the necessary software to get you going quickly. So if you want to start building ML applications quickly, you can have a Jupyter notebook complete with TensorFlow and PyTorch provisioned for you quickly on GCP. There's not much configuration you have to do. It's simply like on-demand, machine learning resources or machine learning environment for you to start doing like ML right away. We also have various training and prediction services, so you can train your models leveraging the vast compute resources of the cloud. With this, you get access to our HPC resources, like our GPUs or our TPUs, our tensor processing units, which are our custom chips made specifically for machine learning. Now that TPU is another differentiator that Google has when it comes to our product compared to other cloud providers. All right, so we've showed you some pretty cool tech and some of the transformational things our customers have been doing with Google Cloud. So the bottom line here is that Google is committed to healthcare. This is a key vertical for us and one that we've invested heavily in. We have very deep partnerships with several providers, payers, research, and commercial healthcare organizations. And we'd love the opportunity to partner with any of you that are attending this webinar, so please do reach out to Carahsoft or your Google rep if there's anything more that you'd like to learn about Google Cloud. So with that, I'll go ahead and hand it off back to Harper.
Awesome. Thanks so much, Jeff. We do have a few questions. If you have any questions to ask, please enter them in the chat pod to your left. Our first question is, which version of SHIR? They are not all compatible.
SHIR, you said? S as in Sam?
F
or
as in
FHIR? Oh, fire. Okay. Which, sorry, can you repeat the question again?
Which version of SHIR? And then in parentheses, they are not all compatible.
Okay.
This is from your first demo.
Yeah, for the Cloud Healthcare API. That's a good question. Let me get back to that person. Can you take note of that question so we can follow up with them?
Yes, no worries.
I want to make sure I understand what kind of versions of Fire they're working with, and then we can go ahead and give them a little more info on that.
Definitely. And then the next
Thank you.
question is, how does the Cloud Healthcare API deal with protected health information, or PHI?
Yeah, so that's a question we get often. So the Healthcare API does provide capabilities to do de-identification of several types of data that are stored on the service. It includes de-identifying structured medical records in FHIR format, as well as DICOM medical images, both metadata and pixel data. So, there are options that you can configure, and there are ways that you can do cloud data loss prevention that are natively built into the Cloud Healthcare API.
Great. And then the next question is, with BigQuery, am I paying for virtual machines that are always on?
So no, you're not. Awesome thing with BigQuery is that it's a managed service. So you're only paying for the storage of that data, which is actually cheaper on BigQuery than it is for our object storage service, GCS. So when it comes to queries, you only pay per query. So depending on how much compute that query needs, that's how much you'd be paying. But when you're not running any queries, you're not paying for any compute. It's really an on-demand service that's optimized. So you only truly pay for what you use, and you don't have to pay for like idle time.
Awesome. Thank you. And then the next question is, can you define custom info types with Cloud DLP?
Yeah, you can actually customize um, different info type detectors so that Cloud DLP will inspect or de-identify sensitive data that matches patterns that you specify. So for instance, if you have like account numbers, right, that follow a certain format, you can create a custom info type for that format. So short answer is yes.
Great. Thank you. And then we have no other questions. If everyone could take a moment to answer the polling questions, that would be greatly appreciated. I want to thank all of our participants as well as Jeffrey for being with us today. We hope our webinar has been helpful for you and your organization.
Thanks. Bye, everyone.
If you have any further questions or would like to request more information, please feel free to contact Amir Wagner at Carahsoft. His contact information is displayed on your screen, so please don't hesitate to call or email him. Thank you and have a great day.